Hello students. This is my lecture number 11. So last two lecture I have discussed about some numerical on heat and work. So this is my third lecture on numerical, and total 10 lecture has been uploaded. Okay, so let's start. So last class we discussed about this numerical, where this was your numerical and it was discussed. Now next lecture, this is my last lecture on numerical. Okay, so here you can see, consider a gas contained in a piston cylinder assembly as the system. The gas initially at a pressure of 1000 kilopascal and occupies a volume of 0.1 meter cube. The gas is taken to the final state where pressure is equal to 200 kilopascal by the following two different processes. The volume of the gas is inversely proportional to the pressure. The process follows the path PV to the power n is equal to constant, where n is equal to 1.4. Calculate the work done by the gas in each case. Okay, so what is the work done by the gas? You have to find out that one. Okay, so you can see the initial pressure is given, that is your 1000 kilopascal. Initial volume is given 0.1 meter cube, and final pressure is given 200 kilopascal. So the final volume is not given, I think. So first process is volume of the gas is inversely proportional to the pressure. Okay, so we know that if this relation, we know P1 V1 is equal to P2 V2, or V2 by V1 is equal to P1 by P2. So from that relation you can find out V2. So this is your V2, 0.5 meter cube. Now as it is saying that P is inversely proportional to V, P is inversely proportional to V, so ultimately PV is equal to constant. So that is your isothermal process. Now for in case of isothermal process, the work done is equal to P1 V1 into ln V2 by V1. So this is your equation. So you can see P1 V1 ln V2 by V1, initial pressure you know 100 kilopascal, initial volume you know, and ln 0.5 by 0.9, that this is your final volume by initial volume. So ultimately 160.94 kilojoule. So that is the answer for the first question. Now next question, it is telling that P V to the power n is equal to constant, where n is equal to 1.4. That means it is your adiabatic process. Okay, or your polytropic process, you can say polytropic index. Okay, so 1.4 is this. So the final volume, by the help of this formula, P1 V1 to the power n is equal to P2 V2 to the power n, by the help of this formula you can find out the V2. Now work done is this, the formula of the work done, P1 V1 minus P2 V2 by n minus 1. So very simple, already it is discussed, though ultimately this you are getting this 150 kilojoule, that is your work done. So for the second case it is your 150 kilojoule, and for the first case it is 160.94 kilojoule. Now we can conclude by the help of these two process. You see here, for the isothermal process, the work done what we are getting, that is greater than the polytropic process or the whatever the adiabatic index. Okay, so we can say that work done for constant temperature is greater than work done for the polytropic process. Okay, or polytropic process. Okay, so this by the experimental value, or the from the value we can get this one. Okay, so next problem, a mass of gas is compressed in a quasi-static process from 80 kilopascal 0.1 meter cube to zero point 4. First of all, I need to say that please you just go through the problem and pause my video and solve it yourself. Okay, then come to my, that means after solving out you can see the your solution. Okay, so 0.1 meter cube to 0.4 megapascal, 0.03 meter cube, assuming that the pressure and volume are related by P v to the power n is equal to constant, find the work done by the gas system. So as you know, the pressure, initial pressure, final pressure, initial volume, final volume is given, n is not given. So very simple problem, same process, P1 is given, P1 is given, P2 is given, V2 is given, and Ln you can find out by the help of this formula. N is equal to Ln P1 by P2 by Ln V2 by V1. So this is your N 1.337, and this is your formula, work done P1 V1 minus P2 V2 by N minus 1. Okay, now one more thing I need to say, that this 0.4 megapascal, it is your megapascal. So if you are converting in terms of pascal, so 1 megapascal is equal to 10 to the power 6 pascal. Now it is taken in given in the kilopascal, so it is taken in terms of into 10 to the 3 means in terms of pascal. So ultimately you are getting this one, this is your joule and minus 11.869 kilojoule. Now you can see this is your minus, so initial volume is 0.1 and final volume is 0.01, so you can see that volume is decreasing, so the gas is compressed. Already it is saying compressed. Now gas is compressed means what? Work done on the system, and it is quasi static process, very slow process. Okay, so minus, the negative sign indicates that the work done on the gas. Okay, so the negative sign is, that means the sign is very important. If you are telling that work done by the system is your minus 11.869 kilojoule, then it is right. But if you are saying that work done on the system is minus 11.869, then it is not correct. So you have to say that if it is minus, then work done by the system. If it is plus, then work done on the system. Okay, so sign convention is very important. Next problem. In this problem you can see some data is given, pressure, volume. So in pressure, when it is your 100 kilopascal, the volume is your 0.1 meter cube. You can see this is your unit, and here pressure is your 37.9 kilopascal. On that time the volume is 0.2 meter cube. Now last process, that last state 1, state 2 and state 3. Then in this state 3 you can see the pressure is given 14.4 kilopascal and volume is 0.4 meter cube. Now read the problem. A piston cylinder device with an air at an initial temperature of 30 degrees centigrade undergoes an expansion process for which pressure and volume are related as given below. So P V1 V1 to the power n is equal to P2 V2 to the power n. This is the relation. Okay, calculate the work done by the system. You have to calculate the work done. Now by the help of this equation you can find out the n. So n is equal to 1.4, as you can see. Okay, so the process obeys the relation P V to the power n, that is 1.4 is equal to constant. Okay, which process I can see by the help of this polytropic index. So 1.4 we are getting n ka value, a value of n, so P V to the power n is equal to constant. Now what is the work done for 1 to 3? You can see you are taking P1 by P2 V2 by V1. So in this time 100 and 37.9. So these two relation, these two values you have to take, these two state, P1, this is P1, this is P2, this is P3. This one is your V1, V2 and V3. Okay, now if you are finding out the work done for process 1 to 3, then P1 V1 initial volume and initial pressure minus initial pressure, final pressure and final volume by n minus 1. So put the values 14.4, that means the state 3, this one is your state 3, 14.4, and the volume is your 0.4. So this is your ultimately 10.6 kilojoule, and as it is you are getting is plus, so work done by the system is taken. Okay, so this is the problem. Next problem, this one, this is your homework, you can solve it in your home. Okay, so this is how your heat and work, the numerical chapter has been finished, and I can see the and next different process in the process diagram. Okay, so different processes in the process diagram, as you can see that constant pressure process are there, constant temperature, reversible adiabatic process, constant volume process. Now what is the value of n, where n is the polytropic index? Now if the value of the n is equal to 0, then the we are calling it constant pressure process. Why it is like this? Because we know that P v to the power n is equal to constant. Now if n is equal to 0, then this part will be 0, sorry, no, not 0, this part will be 1. So v to the power 0 means 1. So P is equal to, ultimately this P is equal to constant. Okay, so P is equal to, P is equal to constant. So how it is coming? You know that P v to the power n, again I am telling you, P v to the power n is equal to constant. Now this n is equal to 0, so this part will be 1, so P pressure is equal to constant. Okay, so is it clear? So now this, for n is equal to 0, the isobaric process, constant pressure process. Now if n is equal to 1, it is if n is equal to 1, now coming again, if n is equal to 1, then P v to the power 1 is equal to constant. So it is what? One type of isothermal process. That is why we are taking isothermal process. This one is your isothermal. If n is equal to gamma, then that is your adiabatic process. This one, adiabatic process. Okay, or reversible isentropic process. Reversible adiabatic process or isentropic process. Same. No heat transfer. Okay. And if n is equal to infinity, then on that time volume is equal to constant. So that is why this is your PV diagram, and volume is equal to constant, this is your line. So if you are putting n is equal to infinity, you will be getting like this, V is equal to constant. Okay, and this is the diagram. So for in the MCQ question, it can be asked that if the diagram in the diagram n is equal to 0, then which type of process it is. Okay, so you can say easily by the help of the formula PV to the power n is equal to constant. So I think it is clear. So today up to this. Thank you for listening. Jai Hind.